Hello, my name is Frank Williams. I've been working in the oil business for over 40 years in both drilling and production operations. I have a BS degree and an MS degree from Mississippi State University. I've served as a drilling manager and production manager for many companies in the U.S., Latin America, India, and the Middle East. I feel that one of my best achievements was turning my experience into a production optimizing tool that I am here today to introduce this innovative tool to you. Today, the buzzword in production is optimization. Production analysis must be characterized not only as a science but also as an art. Over the years, many scientific equations have been developed to aid petroleum engineers and management in the selection of the best methods of producing an oil well when it becomes time to artificially lift the fluid. Often these equations alone do not provide the desired results and produce a costly mistake that turns the pump selection into a trial and error process until the correct pumping design is discovered. The high cost of capital expenditures for pumping equipment requires that the most efficient pumping method be determined as soon as possible. If the correct pumping strategy is utilized from the start to optimize production, capital expenditures can be reduced due to the elimination of further pump changes while seeking the best pumping design to maximize oil production for a particular well. Imagine a 100 well oil field, each well having different bottom hole pressures and subject to different artificial and natural pressures, forcing the produced oil into the wellbore. Additionally, imagine that each well configuration has different size production tubing through which the liquid must flow, with different size, type, and capacity of pumps set in the wellbore. Imagine further that placement of the pump depth, pump displacement, pump intake pressure, liquid level above the pump, the viscosity of the oil, and the ability of the production engineer to manage all these variables are constantly in question. In this scenario, it is a surprise that most producing oil fields are not optimized. Of course, remember that you must find some technique to optimize production and to maintain that optimization from this field. To not produce oil that can be produced is many dollars left in the ground. These dollars that most oil companies need desperately. Petro Innova experienced engineers and production scientists have invested considerable time in the development of a computer modeling software package to accomplish this. It takes the guesswork out of production optimization of wells and oil fields utilizing ESPs, sucker rod pumps, and progressive cavity pumps. This computer software model, along with trained production consultants, will allow us to serve as consultants to oil companies around the world to optimize their fields and generate more volumes of oil at a lower lifting cost, which sends cash directly to the bottom line. This production management system, coupled with a project management system, would lower lease operating expense by using acquired data that is not expensive to gather. It will lower LOE costs by supplying the production engineer a blueprint to select the correct size and depth of the pump required to optimize a well, thereby eliminating the unnecessary rig cost that occurs when the wrong pump size or pump depth is chosen. It will lower LOE costs by increasing the number of days that a well produces each year. It will lower LOE costs by giving the production engineer a blueprint to select the correct size ESP and related equipment, such as the size of the electrical cable needed and the size of the transformer required to maximize production. It will lower LOE costs by increasing production if the wells have a capacity to produce more oil than they are currently producing. Our production engineering personnel are knowledgeable in all types of artificial lift systems. Using the computer software model will allow them to make the best recommendations to optimize wells of our clients, and just as importantly, how to maintain optimization of those wells. Using this software on wells in a water flood has proven to be very beneficial to the reservoir engineer. It provides information on each well that the reservoir engineer can use to evaluate how much that well's pressure, reservoir pressure, is affected by the water flood on a weekly basis. It can also be used by engineering personnel to quickly evaluate the potential of wells and fields that are under consideration to be purchased or sold. This proves very beneficial to the buyer in making a bid, since a complete rehabilitation plan of the field can be constructed. It allows the seller to make a more informed judgment when considering bids submitted. Consider this example. Assume that this fictitious field with 100 producing wells, through the efforts of our production management system and oil company, increases production on an average of 5 barrels of oil per day per well. If oil sells for $50 per barrel, then daily cash production from the field increases by $25,000 a day, or $9,125,000 annually. Again, this money goes directly to the bottom line. One must not forget, fixed operating costs for a well that is being produced at its optimized rate is usually the same as a well that is not. This may not appear to amount to a great deal of money, but the example used above is only a small indication of the increased cash flow that may be present in your fields right now. In closing, this tool is designed for optimizing oil wells, auditing production, water flood management, and the evaluation of oil field acquisitions that are under consideration. Thank you, and I am Frank Williams, Chief Product Development Engineer.